Hi, these are some questions that people have requested from the Cambridge worksheet. First one I'll do is exercise 10b, question 11. Now it says the curve y equals ax squared plus bx plus c touches the line y equals 2x at the origin. That means that these two equations will touch each other at the origin. Now this is a parabola that's concave up, and this is a straight line with a gradient of 2. So I'm just going to sketch what the problem actually means. There's many ways we can do this question, but if we've got y equals ax squared plus bx plus c, actually I'm not sure it actually hits there, so I really don't know. Actually, I probably shouldn't draw it like that, but I will. Just one sec. Actually, what I'll do, I'll start again. So this curve touches the line y equals 2x at the origin. All I'm going to do at the moment is draw the line y equals 2x, okay? So that parabola also, it says that curve, which is a parabola, touches this line at the origin, and it's saying that it has a maximum point when x is 1. Obviously, it's referring to the parabola. Now, if the parabola has a maximum point when x is 1, it means that the parabola is concave. Means that the parabola is concave down to have a maximum. So I'm just going to draw what I think the situation looks like, and it looks like this. Now I'd say here's your maximum when x is 1, so your maximum is 1 something. Your parabola touches that line y equals 2x at the origin, and we've got a maximum there. So this is what the situation or the scenario looks like. Now you can approach this a few ways. Look, we know that because they touch each other at the origin, we know that the point 0, 0, the point 0, 0 lies on the parabola, and it is a parabola, y equals ax squared plus bx plus c, and it also lies on the line y equals 2x. Now, when you know that a point lies on the line, you can substitute that point into the line. So if I put, for example, substitute into this line, if I put x is 0, I get that y is 0, but I already know that. So what I'm going to do, I'm just going to start by subbing 0, 0 into my equation y equals ax squared plus bx plus c. And I will get that 0, because y is 0, equals a times 0 squared, which is 0, plus b times 0, which is 0, plus c. Now it appears that c is 0. Now c would have to be 0, because if you see this parabola, it's concave down that passes through the origin, the y-intercept 0. So we've already worked out that c is 0. Now, we know that there is a maximum point on that parabola when x is 1. Now, maximum point is a stationary point. So if y equals ax squared plus bx plus c, then dy dx, or the first derivative, is 2ax plus b. Now, we know that there is a maximum when x equals 1. Now, maximum is a stationary point. Therefore, dy dx is 0, and this is obviously a stationary point. So we know that dy dx equals 0 when x is 1. So we can substitute up here. We've got 0 equals 2a times 1 plus b, which we know that 0 is 2a plus b. Now, that means that we've got a bit of a, we actually can't work out a and b from this yet, because we've got two unknowns, a and b. So we need another equation with a and b. Now we know that there is a maximum, going back up to the question, when x is 1. So far we know that when x is 1, I suppose I can't really find out what y is, okay? So I really can't do much there either. So I can't do much there. So I'll just come back down here, and we still need to think about this a bit more. So looking at this, if we now use the information that we've learned, if you've got a maximum when x is 1, we know that it's concave down there as well. So if you were to do the second derivative, remember this exercise is before we do the second derivative anyway. So if you were to do the second derivative, you would get 2a but we know that it's concave down. All we'd get is that 2a is less than 0. That's not really helping us solve what 0 is. There is another thing that we can do. We know that the line y equals 2x and the parabola touch at the origin. So we know that the solution to, so these are obviously, we can solve those two equations simultaneously. So I've got y equals ax squared plus bx plus c. And I've got y equals 2x. Now, if I want to find the point of intersection, I put those two equal to each other and I get ax squared plus bx plus c equals 2x. So I'll call this equation 2, 3, and I'll just put sub 2 into 3. And I get that. Now I know that c equals 0. So I've got ax squared plus bx equals 2x. And I can, I'm going to take everything over to the left-hand side. So ax squared plus bx minus 2x equals 0. And I'm going to factorize out the x here. So solving this quadratic gives me, if we were to solve this, you'd come up with some expressions for x. But the important thing, looking back up here, is that the parabola and the line touch at only one point. So therefore, the solution to this has only one solution. So if we look back at quadratic equation theory, therefore the discriminant, which is b squared minus 4ac, will equal 0 when you've only got one solution. So I'm going to work out the discriminant for this equation here. Now b squared is b minus 2 squared minus 4 times a is a, but c we know is 0 because it's plus the constant 0. So the discriminant is b minus 2 squared, and that equals 0. So therefore we get that b is 2. Now we can come back up here. Now if b is 2, I can sub b equals 2 into equation 1. Sorry, running out of room. Sub b equals 2 into equation 1, and I get 0 equals 2a plus 2. So therefore 2a is negative 2, so a must be negative 1. So therefore we've got that a is negative 1, b is 2, and c is 0. So the thing that got us through this question is knowing that this parabola and this straight line only meet at one point. So you solve simultaneously to find the point of intersection, but we actually don't need to actually, look, we know that they intersect at 0, 0. So we don't need to do that. What we need to do is the fact that they only touch each other once means that there is only one solution to this equation here. And that's why we need to look back at quadratic theory. When you only have one solution to an equation, then the discriminant equals 0. Okay, so we use that bit of information. Remember, this is, there is no c term here, so here the c is 0. So then we only ended up with a b, and we were able to solve for b, and then we were able to substitute the b back in here and work out the a. Okay, I think I'll now have a look at question 10. Look, a few of you have been asking about that. I've already worked out the solution to that, so I'll just talk through it. Now here's question 10. I've already worked this out. The curve y equals ax squared plus bx plus c passes through the points 1, 4 and negative 1, 6, and it obtains its maximum value when x is negative 1/2. So there are 3 pieces of information here that you can use. You know that the points 1, 4 and negative 1, 6 lie on the curve. So you can substitute x is 1, y is 4 into this equation. You can also substitute x is negative 1, y is 6 into this equation. So that's what I've done here. Points 1, 4 and negative 1, 6 lie on the curve. You can substitute them into the equation, into the ordinary equation, because they're points on the curve. So we substituted 1, 4 and I got this. And then I substituted negative 1, 6 and I got that. So notice we've got 1, 2, 3 unknowns, but only 2 equations. When you're working with simultaneous equations with 3 unknowns, you need 3 equations. So we have to use another piece of information. Now, the other bit of information is that we've got a maximum value when x is negative a half. Now, a maximum is a stationary point. Remember, there are three types of stationary points: maximum, minimum, and horizontal inflection. So, because we've got a maximum, so stationary points, you know, a maximum is a stationary point. So therefore we know that we work out dy dx, the first derivative, and we get, if you differentiate this, if y is ax squared plus bx, we get dy dx is 2ax plus b, which I've got down here. Okay, now we know that when x equals negative a half, you've got a maximum, which is a stationary point. So when x is negative a half, you substitute dy dx is 0. So you do that in this equation up here. So we put dy dx is 0. It equals 2a times x is negative a half plus b. You work this out and you get that negative a plus b is 0. In other words, a equals b. So now what we can do, we can substitute a equals b back into equations 1 and 2 up here. And if we put that a is b here, and if we put that a is b here, we only end up with two pronumerals. This will be b plus c. This will be b minus b plus c. So we do that, and substituting into equation 1, we get 4 equals b plus c, which is 2b plus c. And when we substitute into equation 2, we get 6 is b minus b plus c. So 6 equals c, because they cancel. Then we can just substitute c equals 6 into this equation up here and work out b. And then we can substitute, because we know that a is equal to b from up here, and b is negative 1. So a equals b, which is negative 1. And so therefore we have all the solutions there for a, b, and c. Okay. Now I'll look at question 12, because a few people have asked about that as well. Now, question 12 in 10b is similar to question 11. The thing here is, it says that this function has a minimum at negative 227 and a maximum at 1, 0. Now, you might think that there are only two pieces of information given, but there are actually 4 pieces of information. See, you can substitute the point into the normal y curve. So because negative 227 is a point on the curve, you can substitute it into the actual equation of the curve. 1, 0 is also a point on the curve, so you can substitute it into the equation. And then we know that we've got a minimum, which is a stationary point when x is negative 2. So when x is negative 2, you also know that dy dx is 0. And you also know that you've got a maximum when x is 1. So the other 4th piece of information is that when x is 1, dy dx is 0, because a maximum is also a stationary point. So, see, when you look at the question and you're trying to find a, b, c, and d, you're going to need 4 equations to be able to do that, okay? So because we've got our 4 pieces of information here, that's going to lead to 4 equations, which will allow us to be able to find a, b, c, and d. So we start with substituting the negative 227 into the equation, and we get this. Okay, so you can do that. Then we substitute 1, 0 into the equation, and we get 0 is a plus b plus c plus d. Then we use our 3rd piece of information about the first derivative being 0 when x is negative 2, and the first derivative being 0 when x is 1. So we work out the first derivative, like differentiating the original function, we get that. We substitute x is negative 2, dy dx is 0. Up into that, we obtain this 3rd equation. Sorry, you can't see that. There's the 3rd equation. Then you substitute x is 1, dy dx is 0 into that derivative, and you'll end up with this 4th equation. Now, you've got 2 equations with 3 unknowns, but if you just do equation 3 minus 4, you're automatically going to eliminate this c. So that's a good idea to do 3 minus 4. Now, if you do 3 minus 4, equation 3 minus 4, you get 9a minus 6b is 0. You can take that 6b over, and you can divide through by 9, and you'll get that a is 2/3 of b, or I'm going to write also that b is 3a over 2. because I'm not sure which way we're going to use it, okay? Now, if we now use that bit of information, substituting A is 2/3 B into equation 4, so over here, if I put A is 2/3 B, 2 over 3B, I'm just going to, this equation 4 is now only going to be in terms of B and C. So I've done that, and I get an equation only in terms of B and C, but I also get a relationship between B and C that C is negative 4B. So now I have a few things that I can substitute. I've got an expression for C being minus 4B. I've also got an expression for A down here being 2/3 B. So what we can do is substitute each of those. A is 2/3 B and C is minus 4B back up into equations 1 and 2, which are up here. Now, if we do that and substitute A is 2/3 B, this will now be in terms of B. If I substitute the C as minus 4B, this will now be in terms of B, and I end up with an equation only in terms of B and D. So I do that. I do the same thing and substitute into equation 2 as well, because if A is 2/3 B, this will be in terms of B. I keep the B. I substitute C is minus 4B, and this will now be in terms of B. So I end up with two equations only in terms of B and D. So I've done those there, substituted A is 2/3 B and C is minus 4B, both into equations 1 and 2. This is substituting into equation 1, and that's what you get. When you substitute into equation 2, you get this down here. Now we can just do equation 5 minus 6, because the D minus D will go, and you will get that 27 minus 0 is 27, is 6 and 2/3 B minus negative 2 and 1/3 B, which will be 6 and 2/3 plus 2 and 1/3, gives us 9B. B is 3. Now we know that if B is 3, we know that A is 2/3 of B. So 2/3 of 3 means that A is 2. We also know that C is minus 4 times B, so C will be negative 12. And D, I just don't have room for that one, I'll just do it over here. D, just go and find an equation with D in it. I'm sure we'll find one here. There's one here, or there's one here. We can substitute B is 3 into this equation. So we would get 0 equals, now minus 2 1/3 is minus 7 over 3 times B is 3 plus D. So I think we get D is, they cancel, you get D is 7, okay? So I'm just going to check that answer. I know it's a little bit messy, but I think it's correct. And exercise 10B, yes, D is 7, C is negative 12, A is 2, and B is 3. So that is question 12, okay? 10B is another one, and it says, part A, if the function of x is equal to 3x over x squared plus 1, you're supposed to show that f dashed x is 3 bracket 1 minus x times 1 plus x over x squared plus 1 squared. Now, you would obviously use the quotient rule for that. I'm not going to do it, but that's how you would do it, okay, for that part A, and I'm sure you'll be able to do that, okay? Then it says to find any stationary points, find the stationary points and analyze the types, and then they want you to sketch the curve. Now, I think you should be able to do this as well. You know, when you put that equal to 0, when you I'll just go through it a little bit. But when you do come to solve this and put it equal to 0, you don't worry about the denominator, because the only way that this is going to be equal 0, this expression, is if the numerator, you have to have 0 divided by something is 0. And that denominator can never be 0 anyway, because you can't do something divided by 0, that's undefined. So you are going to have stationary points. So you are going to have 3 bracket 1 minus x times 1 plus x equals 0. Therefore, you've got stat points when x is 1 and negative 1. Now, you can substitute back into the original equation and get all the points. You can do the second derivative. Actually, see, this one, I would not do the second derivative. So this is a really typical example. Like, you really don't want to be differentiating this a second time. So what you want to do with this one to work out the nature of your stationary points is definitely to do the table of values with the first derivative. So I said earlier, there are times when you really do not want to be doing the second derivative to work out the nature of the stationary points, and this is one of those times. That will take you a long time to do the second derivative, unless the only way you may consider doing the second derivative of this would be to simplify that numerator. That might be easier. Remember, this is the difference of two squares. You've got a minus ba plus b. This is really 1 squared minus x squared. So the numerator is really 3 minus 3x squared. You may consider doing the second derivative that way. Okay, that might not be too bad, but I think it might be quicker just to do the substitution into the first derivative. See, the thing is, you actually don't even sometimes have to work out what it is. We know that when x is 1, that this is 0, okay? Now, if x is 1.1, what you can do, if x is 1.1, you can just see whether things are going to be positive or negative. We know that no matter what x is, the denominator is positive. If x is 1.1 here, we get 1 minus 1.1, that will be negative. And 1 plus 1.1, that's positive. So I've got a positive times a negative is negative divided by a positive. This is definitely negative. If I substitute in 0.9 into that first derivative, 1 minus 0.9 is positive 0.1. 1 plus 0.9 is positive. So I've got a positive times a positive over a positive. This is positive. So therefore, you've got a maximum. You've definitely got a maximum when x is 1. You can do the same thing here, looking at 2 points on either side of the negative 1. So if you've got negative 1.1 here, you get 1 minus negative 1.1, which is 1 plus 1.1 is 2.1, and 1 minus 1.1 is negative. So a negative times a positive, I've got a negative here because that's always positive. I know I've got 0 for my first derivative there, and negative 0.9, 1 minus negative 0.9, well, that's 1 plus 0.9, that's positive. 1 plus negative 0.9 is still positive because it's positive 0.1. Positive times a positive over a positive. This is a positive. You can actually work out what it is, but this is a quick way to do it. So you've got negative gradient, 0 gradient, positive gradient. You've got a minimum. So therefore, we've got a maximum and a minimum. So they wanted you to analyze those stationary points and sketch it. Now, when x is 1, I'm just going to go into the original curve. So I've got a maximum. When x is 1, 3 times 1 is 3 over 2. So first maximum is at 1, 3.5, and the minimum is at negative 1. When you've got negative 1 here, you've got negative 3 over 2, negative 1.5. So this is what our curve looks like. So let's have a quick look. A quick sketch for part C. It says to sketch it. Now you've got a maximum at 1, 1.5. You've got a minimum at negative 1, negative 1.5. It looks like when x is 0, if you look at the original equation, when x is 0, you get 0 over 0 plus 1, so it's 0 over 1, which is 0. The y-intercept is 0. Looks like the equation looks something like this. Remember, okay? Bit of a weird one. So we've got 1, 3 on 2, negative 1, negative 3 on 2. If we were asked, there would be an inflection somewhere around here if we did do the second derivative, but we didn't, okay? I actually have made a little mistake here, assuming it comes down, okay? But look, when we do some more, curve sketching this week, the actual curve doesn't go like that. What I could do, go to the original function, because it does look a little bit like a hyperbola of some sort. So just substitute a big value of x, for example, when x is 10, you get 30 over 101, which is about 30 over 100, which is about 3/10. So it actually, when x gets really big, the curve actually goes like this. And you can do the same thing here when x is, say, negative 10. You get negative 30 over, like, negative 99. That's a very small fraction as well. So what happens is the curve actually looks like that. So Look, we'll be doing more of that. This is more like a 3-unit sort of curve here, because just finding those stationary points, it's not quite enough. So we'll be doing this later, probably next week, okay? So the curve looks like that. So it then says in part D, it says how many roots, so this is the bit that I really want to talk to you about. So how many roots does the equation 3x over x squared plus 1 equals c have for, now, part A, for C greater than 3 on 2. Now, when you've got 3x over x squared plus 1 equals c, it's like you've got the graph y equals 3x over x squared plus 1 and you're drawing the graph y equals c. So when you've got something like this, 3x over x squared plus 1 equals c, you can solve it simultaneously by sketching that and sketching y equals c. So in this case, now if that equals c, we want 3x over x squared plus 1 to be greater than 3 on 2. So we're saying 3x over x squared plus 1 equals c. So we want, how many roots does the equation have for c greater than 3 on 2? In other words, if that is bigger than 3 on 2. Now, here is, so we're saying we should sketch that, which we have, and y equals c. Now, in our first case, y equals c happens to be 3 on 2. So I draw in the line at 3 on 2. Now that does touch 3 on 2, but is this curve, which is down here, ever greater than the line y equals 3 on 2? Well, no, it's never greater than the line. It's always below 3 on 2. So that has no solutions, as the graph y equals 3x over x squared plus 1 is always lower than the line y equals 3 on 2. Now for part B, it says when does c equal 3 on 2? So how many solutions does that equation have? So in other words, how many solutions does 3x over x squared plus 1 equal 3 on 2 have? Well, here is the equation, 3x over x squared plus 1, that's its graph, and it actually touches the line y equals 3 on 2 once. So therefore this has one solution, as the curve y equals 3x on x squared plus 1 touches the line y equals 3 on 2 once. For part C, we're asked how many solutions does this have, where C is in between 0 and 3 on 2. In other words, where 3x over x squared plus 1 is between 0 and 3 on 2. Now, here is y is 0 and here is y is 3 on 2. Now we're asking how many times, for values of y between 0 and 3 on 2, if I do any values of y and draw them across here, you'll see that those red lines cut that curve twice. So therefore we have two solutions, because the graph y equals 3x over x squared plus 1 touches any lines from y equals 0 from between y equals 0 and y equals 3 on 2 twice. It cuts them, not touches, cuts. So two solutions, because the graph y equals 3x over x squared plus 1 cuts the lines, any horizontal lines drawn above y is 0 and less than y equals 3 on 2. So for example, if I drew the line y equals a half here, that black curve cuts it twice. If I draw the line y equals 1, my curve in black cuts it twice, so there are two solutions to it. Now for part D, I'm just going to do it here, which was where C equals 0, which is this line here, which is actually so C0 is asking where does 3x over x squared plus 1 equal 0? Well, that black curve equals 0, has a y value of 0 when x is 0, so that it only cuts it once, so therefore that has one solution, okay? Because the black curve, the curve drawn in black, cuts y equals 0 once, okay? So therefore that has one solution. All right, that's that question, which is question 8. Now that's going to be the end of this video. Sorry that's a bit messy. Okay, thanks.